Okay, so yeah, I'm Richard Honey. I am indeed at Samsung. I've been here for coming up to a year now, and I run the ecosystem group out of the R&D section. I wanted to talk, essentially repurposing the talk that I've just given at SDC, which is the Samsung Developer Conference mentioned in the slides here, but on top of the content, which I'll probably just try and spend about 10 or 15 minutes on, make myself available to talk about, to chat about the kind of trends I see in the industry and the stuff that led us to the position we're on, rather than focusing too much on Fortnite only. Anyone heard of Fortnite? Two. That's more than two. That's more than three, in fact. I know, because I'm in computers and I can count beyond three. That's my best joke of the day, actually, so thank you for that. I don't know if there's going to be another joke. This is me standing in a corridor, just so that you know who I am afterwards if you want to come up to me and ask me questions. And this is the content which I actually presented. Okay, so the fundamental theme here is getting the technology in games, getting the companies in the ecosystem of games to deliver the content on the platform with a long-term view in mind. So we set out back in 2016 with the very early versions of Vulkan, but we also set out before that. So the plan that's being executed at Samsung is actually about a 4-year-old plan to get to the stage where we have Fortnite and others highly optimized on our platform. Part one of that was getting Vulkan in place. So Vulkan is a low-level API. It's fundamentally different from the predecessor APIs. Everyone know what an API is? Anyone want me to explain what an API is? Maybe that's a better question. Good, good. I'm glad no one asked me to explain that. So these APIs are industry standards, because without an industry standard, you don't get to get serious adoption. You can do a little bit of differentiation. You can create a certain amount of momentum on your own. But if you're a phone manufacturer, you want to work through industry standards pretty much all of the time. This was the first time we released Vulkan code out into the wild in 2016, and it was part of the S7 launch. Roughly 2 years prior to that, we set out with the Kronos group in mind, with the intention of setting up an API that would solve some of the problems that were preventing proper quality games from PC or console coming onto our platform. And the decision was taken back in 2014 that a low-level API which was CPU efficient, which would allow a GPU to run at much the same efficiency, would be a critical part of that. And it might seem odd that we would only try to raise the efficiency on the CPU side, but actually you can drive a GPU hard enough using OpenGLES. What you can't do is drive a CPU sufficiently efficiently. If you try to use OpenGLES, then what you find is that the CPU is the hot spot in the chip, and it overheats the GPU and keeps the GPU from actually doing what you want it to do. So it's about getting the CPU out of the way. There were a number of APIs which were being worked on at the time. Apple, Google, AMD, others were coming up with APIs to try to solve these bottlenecking problems. Microsoft is the other very visible one, it's DX12. And Samsung decided to put its weight behind Vulkan and invested very heavily in Kronos, to the stage where now we hold a board position. I'm privileged to have just moved on to the board at Kronos, and we try to push that standard in a way that is efficient and effective, rather than just pushing it for its own sake. So getting to 1.0 was the really important stage. Getting to 1.1 is important, but less important, and 1.2 is, at the moment, barely relevant by comparison. Okay? The critical stuff is to get the infrastructure into a sufficient state, and then actually slow things down. Don't have things moving too fast. There's a history with DirectX, for example, back in the early 2000s, when there was a new version of DirectX every year, and that, I think, turns out to be counterproductive. You slow down the adoption of each individual API because people are wondering whether they should go for this one or that one. With Vulkan, we're essentially on 1.0 to 1.1 at the moment, and those are the only two choices. OpenGLES, anyone care to guess how many versions of that there are out there? don't know, we're on 3.2, 3.1 and 3.0 all shipping. There are versions 2 before that, versions 1 before that. It's a menagerie, and as a games developer you don't really want that. You want a nice solid target to aim at. So we worked with Epic. We didn't pick Epic specifically because of Fortnite. We picked Epic because they're one of the 2 critical engine vendors in the market that we cared about. So Epic and Unity control something like 70%. They supply the engines for about 70% of all mobile games. That's quite astonishing. Just 2 engines. So if we're able to impact those engines, we impact all the games that turn up on our platform. So there we are. We produced a lovely demo. It was quite nice. And as a result of that demo in 2017, we were able to start working on showing tangible benefits in gameplay. Don't know how many of you will know this game, Lineage. It's one of the games that made it into the top 10 around the world. About 15% better performance and a somewhat more stable frame rate on average. 15% better performance means that you can push the game's availability down in the market as well, but mostly it's about a better experience because the frame rate for these games is often borderline acceptable. You're on the 30 frames a second or so area, rather than the 100 frames a second you might see on a PC. PUBG Mobile. Along with Fortnite, this is one of the really big games in the world at the moment. So I've been chatting to 1 or 2 folks about working with Tencent. This cooperation where we've done this work with this particular game, PUBG PlayerUnknown's Battlegrounds. This is fundamentally a cooperation done with Tencent out in China. We have a custom Unreal Engine 4 engine. We've put in the multi-threading because the game didn't implement that, and we've reduced the CPU load very substantially. We have about a 30% improvement in frame rate. So OpenGLES was indeed a bad place to be. There's a lot of discussion about whether OpenGLES wasn't in fact the right thing. Going to Vulkan was a bad idea. Vulkan is a hard API to program for. It's a difficult one, but the benefits are quite substantial. And we now have the best experience you can get, I reckon. We haven't released the Vulkan build of this, but we're about 60 frames a second in HDR mode. HDR is high dynamic range, so it's a very realistic kind of view of the world. The darks are dark, the lights are light, and the contrasts hold together well. And you can see that using Vulkan has given us that substantial benefit. We've got both a better frame rate and a more stable frame rate. But it turns out that the stable frame rate is the big deal. I was chatting with Frank at Intel and we were talking about quality of service. Frank pointed out that quality of service is a big deal. And actually I did some digging in the big data side at Samsung recently, and I was asking, can you quantify how important quality of service is? Can you show a correlation between stable frame rate and user retention? And it's an interesting question because most of the answers you get are anecdotal. Oh yeah, I got fed up with that game. It took too long to load, so I abandoned it and uninstalled it. It was a fairly unstable, it seemed a bit glitchy every now and then, so I got rid of it. But you're asking one player and you don't really know whether that tells you about the whole ecosystem, about the population of games players. And it turns out that it's true. There is a very clear correlation in the big data. So this is for all users, not just for the high-end folks. There's a very clear correlation between stable frame rate and player retention. When the frame rate varies, even though it might be higher than an acceptable average frame rate, that variability is what costs you players. We worked on Final Fantasy Pocket Edition. That's has released this year. Again, it's built on Vulkan. We've done some very specific work with them on things like post-processing to make sure that their engines are efficient. But most importantly, you'll notice that it's another engine game. It's built, not this time on Unreal, it's built on Unity. So that means that we've now got experience of working with shipping high-end games, high-profile games, which use these dominant APIs for the mobile business. I don't have the numbers on frame rate there. Oh, there we are. On average, about 10 frames a second improvement, so very substantial benefit to the user. 4 camps, as we call them, where I send out engineers from the ecosystem group, and they work on site with the games developer. And in some cases, we've been able to double the frame rate. So this 4-year plan of trying to change the market so that instead of having games shipping on a fairly okay kind of experience, instead we're shifting to a much higher quality experience on Samsung devices. And actually, because we're working through standards, the benefits come to pretty much everyone. We've done a great deal of work with Fortnite. I've sent engineers to North Carolina to work locally. We've had folks from ARM and Qualcomm participate in these efforts with the games development too. At the moment, we're on something like a 20% benefit in terms of frame rate compared to where we stood with the original ES version. And most importantly, I guess, is what's not stated on the slide, that because this is an Unreal Engine game, and it's shipped by Epic, the code changes that we make propagate into the engine. So we've been able to change the way the engine fundamentally operates for other games in the future too. So we've reduced the load on the CPU and the GPU, which means that we can now bring this kind of console quality experience across with many more games in the future. 20% frame rate improvement and significantly more stable frame rate, which is where we like to be. There was a presentation on this at SDC yesterday. Black Desert Mobile is another example of that. I'll try and keep that one short. 100 sold another one, another top 10 in the world game at one point. And the list of titles there is quite a big list, but there's a list as long as this, which is games in the pipeline now. So that when we set out in 2014 and knew that we needed to improve the APIs, we needed to improve the hardware, we needed to improve the infrastructure for the ecosystem, we knew that we would get a kind of exponential wave of adoption of this. It's not for everyone, which is why we do it through the engines, so that it becomes for everyone whether they know about it or not. Vulkan's a difficult API, as I mentioned. It's a long list of titles there. And the cooperation that we have with games developers has got to the stage now where, I thought I had a typo in there. Someone told me yesterday that when I presented this slide, it said the full flat version, but it's the full fat PC version. Everything from the original game, Rome Total War, is now coming to mobile. Feral have announced that they'll publish this in the next short-term future, sometime in 2018 is really what they said. And this is absolutely a lovely example of the kind of cooperation that we've tried to build. What I didn't mention actually is that the engineering team that supports folks like Feral and Tencent and Epic, that team didn't exist 4 years ago at Samsung. So when the decision was taken to go after this, there were a number of teams that needed to be built up for it, as well as putting the API in place. But now we got to the stage where Feral made this announcement, and they were kind enough to announce it at SDC that the game is coming to Android, and it will be just the same as the original PC version, which my sons used to love. Too. The groups that we have, like I say, 4 years ago, these teams didn't exist. We've now got about 30 staff dotted around the world doing games development work. Out in the USA, they're in Mountain View. In the UK, they're in my office, just outside London. We have folks in Kiev in the Ukraine, Nanjing in China, primarily for the local market, and folks in Korea. But although we have 30 staff dotted around the world, I'm pleased to say we have effectively an unlimited travel budget. We're able to go anywhere and solve any of the problems that matter to us. We take pictures when we go out, and there's lots of happy people there. It's a young, enthusiastic team. They travel a great deal. Most of these are on-site photos from working, either doing presentations with games developers or actually going out and working side. One thing that we did very recently, which didn't make its way into this photograph, we actually ran a Vulkan programming camp out at Tencent, where Tencent were kind enough to send us about 50 engineers. So the adoption of the API that we've been nurturing for these 4 years, I think we're now there. We got it. The team itself, game optimization, we'll do the optimization all the way through the pipeline. It can be a very profound engagement. As I mentioned, we went to Okinawa 4 times to work on it. We do a lot of work. We've got better tools than most people have. Probably the one weakness in the 4-year plan that we had for this is that we didn't address tools aggressively enough. We're working quite hard to improve the tools at the moment, and actually we announced an interesting new tool which is just on everyone's phone. GPU Watch and SDC. And it just comes if you have Android P. It's the new version of Android that's coming in the next handful of months. You can get that tool on your phone whether you're a games developer or not, and it doesn't bother you if you're not. Right, so questions. Questions is actually more a chance for me to ramble if we want to discuss a bit, because I like rambling. Let's see, are there any questions, or shall I just ramble about stuff? Yes, sir.
The frame rate's almost so things that the CD guys all that kind of stuff. Doesn't that mean that people who have a Samsung phone that's going to have a clear advantage over people that don't have a Samsung phone?
Okay, so the question is, I think, is this technology effectively limited to Samsung devices and therefore not available to others? And I think, although I wasn't in the conversations 4 years ago, because as I mentioned, I was only joined Samsung a little under a year ago, the decision was clearly taken that this would work through standards. So actually the benefits show up everywhere. Otherwise the games developers wouldn't really follow us. We could have gone for our own API, and we probably could have made an API which is more efficient. We could have followed Apple's path, for example. Apple have their own API called Metal, and there's their approach. So I'm not here to bash Apple, but I might as well take the opportunity. Their approach is the closed wall approach to life, yeah? Bring everyone into your ecosystem and try not to let them out, and just maximize the revenue there. And I understand from a business perspective that could be an entirely reasonable way to go, but it isn't, philosophically, it isn't my preference, and it isn't the way Samsung wanted to go with this. The Vulkan API is available on desktop PC. In principle, you could put it on a console and ship the console with it. Effectively, that's what the Nintendo Switch runs on. It's certainly available for Linux and so on. And all of the optimizations which are Vulkan optimizations, therefore propagate through that entire ecosystem and everyone gets the benefit. So if I name other Android vendors, every one of them that ships a quality Vulkan driver will get the benefits. It turns out that we work very hard at Samsung. This is going to sound like me being smug about the decisions that are taken inside Samsung, and maybe a little bit I am. We work very hard to focus our driver team just on game optimizations, for example. So actually, we want a highly optimized driver that works in a generic way. And one of the problems philosophically that we had with the OpenGLES driver is that usually when you have an OpenGLES driver, the best way to create an optimization, if your customer comes to you, I'm thinking about the situation that ARM are in, or Qualcomm are in, or anyone else who produces a GLES driver. The problem is, someone comes to you and says, oh, I've got this problem with it not running fast enough in such and such a case. Usually the trick is you put in a special optimization for that case, and then you ignore the fundamental problem underneath that the API just doesn't map very well onto the problem that it's trying to solve, and it doesn't map very well to the hardware. That's not the case with us. We deliberately designed the hardware to be very Vulkan friendly. We designed the API to be as thin as possible so that the optimizations are always just make Vulkan better. So that every time we optimize for a game, those optimizations actually propagate to all other games. And if other people implement their Vulkan drive as well, then those people get the benefit as well. And what I never hear, and I actually checked this so that I could feel comfortable saying it publicly in the future, we never tell people to optimize just for benchmarks. We never cheat at benchmarks. That's my clear understanding about the way Samsung approaches its software story. We don't do that. And I know that's not true. Well, that's a little unfair. I believe that's not true for all vendors in the Android space. There is an effort to optimize in a valueless way just to improve benchmarks from some companies. And I know that that is not the case for Samsung, and I'm proud of that fact. If I found that was not the case, I would go in and fight for changing it. But that's the right way to build an ecosystem that is forward-looking. As I say, if you optimize for a particular game, and these benefits therefore propagate across all games, everyone that uses this particular kind of style of rendering will see a benefit, whether it's PUBG or not. If you do those optimizations right, then the apps run faster everywhere, and it is not a Samsung-specific benefit, but we drive the ecosystem forward. Now, there are then things that Samsung will want to do on the business side about monetizing and bringing people into our ecosystem for the business sales of apps and so on, but we're not trying to lock people to our platform when it comes to the tech underneath it. It's a nice long answer for that. Yes, sir.
Have you used the AR applications within Samsung?
Okay, so the question was, if I repeat it, does AR matter to Samsung? Yeah. Okay, I thought that was going to be my best joke of the morning, and I was going to claim an improvement there. So AR and VR. Neil and I met each other when I was evangelizing, particularly VR, at I think at Intel I was at the time. That might be when I was at AMD around 2014-15, that time frame. And I was pretty sold on the idea. I thought that VR was going to take off this time, that the Oculus Rift and other devices were going to be a really big deal for consumers. And I think that VR is at the moment increasingly irrelevant from our perspective. Now, that's the kind of phrasing that I shouldn't use. It's decreasingly relevant. We thought it was going to be a really big deal, and it turns out it's not. And few people are making money out of VR at the moment. The support that we build in for AR and VR, which is required as part of the operating system of Android, we build in with a certain amount of reluctance these days because the user base is small. That doesn't mean that you can't build interesting AR experiences. And in fact, I know that we're working with a number of games developers, but it's a small number of games developers for AR. And if we do the job right with Vulkan, then there should be relatively little to do infrastructurally in the software. So there are requirements from Google about minimal support for, particularly for AR, and we meet all of those. And actually, getting Vulkan in place is probably the most important thing that we did to make sure that future workload is low for us. It remains a small deal financially. There are games that will use it, and there are games which are interesting, but in terms of it becoming a substantial part of the portfolio, not for a while, I think, and maybe never. I don't know. This is the man who claims to know the future.
This data will create some rambling, which would be great. So, like historically, the goal for rendering has always been to reduce frame rate, reduce render time, reduce latency.
Yep.
So you can reduce the render time, but also you want to reduce the latency from mouse movement to reaction in the world, right?
Yep.
So it's becoming, in the land of AR and VR, it's becoming more and more relevant to reduce latency. So we see these tricks that appear where a render initiates and then there's kind of a last minute tracking update.
Yep.
Like, or there's other tricks, like I think asynchronous time warp or space warp, I can't remember the exact term.
Both of those, yes.
Alright, so I usually work, I'm a programmer, I work kind of one step up in the stack. I don't work as low level. But I'm used to having to like think that way, like, okay, I want this render, can I get the update later? Can I initiate tasks earlier that don't depend on the tracking update? Are you interested, like, as you think more about the low-level access to tracking and rendering, are you interested in making that assumption kind of like core? Of like the tracking update will come at some point later than you initiate the render?
So the answer is yes. If you're going to use a particular pipeline, something equivalent to ARKit or something like that, then it needs to be implemented in a way that has exceedingly low latency, no doubt about that. But the trick there is to get everything into that particular API, to make it all readily available and make the API a standard way of dealing with this problem, rather than to produce a special custom interface that just works on Samsung phones, and only on these particular Samsung phones. And one of the parts of that is indeed to use Vulkan. So we found that a highly productive way. It's an extremely thin API layer, so that the latency is naturally very small. But if you need the special tricks about throwing data around inside the graphics pipeline more quickly, where parts can overtake one another, then use the special APIs for that. If you ever thought about doing that on an individual platform, using the nuances of that platform, then I think you're going down a dead end. So it's all down to get a standard API in place. And there is indeed in Kronos an XR working group. So XR is VR and AR for premises purposes. We do a little work in there. But we think that the infrastructural work for that is pretty much in place now. Certainly with Vulkan 1.1, we have all the facilities that we need, I believe. So that was a big topic of conversation 3 or 4 years ago. Oh, we're going to have to do this, we're going to have to add the asynchronous time loop. And it's got a nice name, hasn't it? Everyone wants to do the time loop again.
You got that.
But really, this stuff should all be wrapped up so that you have one API that solves the problem, and then you can use it everywhere. If you don't have that, then you're in trouble. I think the fundamental problem with VR and AR these days is consumer acceptance of headsets and so on, rather than the technology being in place.
Thank you. More questions?
Okay.
You guys with the
All right. Thank you.